Hey there, Alex again, and it's time for another Q&A video. Now, if you just started watching, you know that I do these once a month or so, where I go back through questions that I got via YouTube comments underneath videos that I posted, or, other questions that have come in from other sources. And if it's something that I think would be important to expound on more, or if I think it would have additional value for the community, I'll pull those up and expound on them a little bit more. So what I do here is a very unofficial video where I just kind of run a camera and I copy pasted a few comments down here. I'll read the person who asked it, I'll read the question, and then I will answer it for you. I'd also like to thank new Patreon subscribers. I appreciate it greatly. I know it says on the Patreon that I will thank each of the new contributors by name, but I went to that page today and it was not letting me in for some reason. I think it has to do with their verification, so sorry about that. And if you're interested in supporting, I always have support links in the description of the videos. I also take this as an opportunity to catch people up for some of the behind-the-scenes stuff. And as you know, we're in the midst of a few different video series, and I have a whole bunch of other experiments that are coming along. And some things are waiting for, one or two different tidbits or thingamajigs to come in. To keep costs down, a lot of these things I order from, overseas, and as you know, it can take up to like 40, 60 days or something for those to come, or sometimes they come in a few days. They find some other warehouse they can ship it from, so you never know. Now, I do apologize because I was going to have another installment of the 32-bit series out this week, which was focusing on hotend and extruder, but I thought that was going to be a nice short, like 10-15 minute video. It ended up I talked for over 2 hours. And I cut it down as much as I could without losing vital information, and it ended up being an hour and 36 minutes. So not too much of a cut there. And I didn't know what to do because obviously I don't want to post a video that long. So I'll probably end up breaking up that content into different segments and working it in a few different ways. But I will have an extruder video out soon. And if you watch the last video I posted, which was like the wacky ideas thing, I touched on a couple extruder things, and when I have some parts that come in, I'm going to do some more hands-on testing, so I guess it's good that I delayed it until then, so I didn't jump the gun, so to speak. And I did get some stuff in already, things that came from, relatively close by. I got a Stepper Online order in with, open this up, several different values of very small steppers that I'm going to be testing out. Another thing that I didn't get to in that extruder video is I had talked a little bit in the Wacky Ideas video about induction heating of hot ends as opposed to, indirect heating like we use. And I'll likely do a series on inductive heating as soon as I get a chance to, simplify it a little bit. And there's some questions that I'll touch on with that. But I did order a couple of these, cheesy inductor heaters from, overseas. This was, $2. And had set up a video where I used this very scientific setup of a volcano nozzle in a ferric sleeve, where just as a proof of concept, I heated that up through there and just pushed filament through by hand. And it did work, but I didn't know what kind of piece of crap these were, and I only actually got a few uses out of it before some of the components burnt out, which is unfortunate because I wasn't recording at the time, and I probably should have. But I did take the hot end and this little meat thermometer that maxes out at 250, something like that. Managed to test it through here, just kind of like that. And then a couple other tests where I had a brass nozzle on top and a steel sleeve on top of that and whatnot. And that heater would get this up to 200 degrees from 0 degrees, or room temperature, not 0. It's obviously not freezing in here, in about 3 seconds. And that was only drawing a couple amps, and this was by far not an optimized circuit. This also uses a resonance loop at one predetermined frequency. It doesn't do any rising edge sync or phase syncing or anything like that. And you can't control the frequency that it's switching at. So if I can't find somebody who's spit out some ready-built Arduino code to mess around with that, I'm going to have to write it from scratch, and unfortunately that's going to have to go back on the back burner again for a little bit until I have time to work on it. Also, as far as other hot end stuff, I bought a few of these J-head heat sinks to mangle. These are pretty cheap. They're a couple bucks a piece. And test some thermal characteristics of that. I also ordered a metric crap ton of different fans and blowers. Whatever I could find for like a couple bucks. And they'll probably take about a month to get here. Various different cartridges, like a whole ton of nozzles and heat breaks. Some heater blocks to test out. I have a copper standard block and a volcano block, and then an identical aluminum like standard block. And then I put in an order to McMaster car for like a whole bunch of copper components. So you know, copper flat rods of different thicknesses, copper crush washers, a bunch of various size copper blocks. You can probably imagine what I'm going to be doing with those. Some heat spreaders that I'll be mangling and soldering and various other things. So I've been a busy bee in terms of that. And that's a video that'll probably be coming out, oh, I don't know, maybe later this month or sometime in December. It's rough around, like, you know, we have a couple holidays, bam, bam, bam around now, so we'll see how that goes. So the most imminent different parts of this series or separate videos are like the hot end extruder thing, which, as you've seen, I'm waiting for some parts. I'd also like to rent a thermal camera to run some tests, so I have to work that out. I have the stepper driver high torque comparison, high voltage video that I've been wanting to do for a long time, and I have, in addition to all the drivers that I had already collected, I put in another order, so here you can see like a dozen different drivers. And what that is waiting on is not only for me to finish up the jig, but rumor has it that Trinamic is making a like step stick form factor of one of their other series of chips, the 5000 series, the TMC 5000s, that'll do like UART or SPI and have different specs and options. So I'm waiting to see if and when that happens before I start this test, because that's something I would really like to include, and I kind of want to do them all at one shot. So just to let you know, I know a lot of you have been waiting for a while for that video, and I really want to do it too, but that's waiting on future developments. And then another part in the 32-bit series that I had mentioned many moons ago when we were talking about 8-bit AVR stuff was that I wanted to do a kinematics comparison. Because when we have these faster clocked MCUs, you can move to more elaborate or mathematically complicated kinematic schemes. And I wanted to do like kind of an overview of what's out there, why it isn't popular, some of the relative like pluses and minuses of the whole thing. And that would feed into doing your own printer designs from scratch, like what some of the pluses or minuses are. I'll throw a whole bunch of like different materials math at people, so hopefully they understand some of the trade-offs that have happened in the past. And as I mentioned before, I'm in the process of building a new kinematics platform, i.e. 3D printer, that I'm going to use as a testbed to run a bunch of these things, because I have my regular cantilever testbed printer over there. I have a few other printers, mostly that are taken apart because I can't keep any of this stuff together when I need to use the parts for experiments. But I wanted to do something completely original from scratch that I could use as examples in there, and that I can also test, you know, hot end and speed things in. So less of like an open frame, easy to film printer, and more of like a rigid high performance printer. And well, it has boxes on top of it, the frame over there, so I can't show it to you. The gantry stuff is here. It's going to be V slots, and I'm experimenting around with different carriages and that type of thing, waiting for a lot of these stupid wheels to come in. I ordered bearings for them. I got like 100 bearings for them that I ordered from overseas. They took 5 weeks to get here, and they sent the wrong ones. Like, slightly the wrong ones, but still the wrong ones enough that I can't use the standard open build Delrin wheels with them. So I'm like, we'll see. I haven't figured out what to do about that. But it threw a monkey wrench in the timeline. And unfortunately, like, that is the thing that I had most of the parts to do, and the only thing that held me up is the stupid wheels. So we'll see. All right, on to the questions. Now, a lot of these are going to be from the most recent couple videos, and I know I skipped the Q&A last month because I had some health problems and other things, The format here is I'll do the person's name, the question, and then respond. So under the wacky ideas, Gary Hauser asks, have you tried the Mosquito hot end? It uses copper. Klipper as stated for firmware, and brainstorming about using a Klipper Vortex tube cooler would require compressed air and some kind of fancy shroud on the fan. Yeah, I've considered all those things. I got the press release email for the Mosquito thing, and it looks pretty cool. It's a pretty slick looking hot end. I don't know how well it performs or anything like that, or what the throughput is. I'd love to try one, but they're expensive. So if the Mosquito guys just want to send me one, that's fine. I'll test it out. But it's like 150 bucks. So a lot of those like sort of like high-end hot ends, there seem to be pretty good, or they have like their USP, their unique selling point, and they're aimed at a particular niche market. And that's not something that I can splash the cash out just to give it a whirl. So we'll see. If it either gets really popular or the price comes down or one just comes my way, I'll check it out for you. Klipper, I've talked about before, and I'll do a full Klipper rundown in the future. If you've seen these Q&As, the last few that I've put out, I said I've been waiting for a few features and Klippers to mature. Between the last Q&A I did and the one before that, a whole bunch of stuff I was waiting for got put in all in one big chunk, and it was awesome. So, unfortunately, I don't have enough machines that are not printing right now to do that review and series, but it is coming. Probably when I get this new kinematics platform put together and run the tests that I need to on that. Okay, and the Vortex tube cooler, yeah, that's exactly what I was thinking with the compressed. That's in response to my saying I would like to see below ambient cooling, and I've messed around with that a little bit. And the Vortex cooling seems to be the best way to do it. Now, those can get down to like negative 15 Celsius or something like that ridiculous. I just want to drop it down maybe like 20, 30 degrees below ambient. I mean, up to 50. And the Vortex coolers are something I checked out a long, long time ago. I have all the math in a folder somewhere. I did a few very limited experiments, and like I said in the video, I want to see if there's a way to rig it up with some, you know, cheapo parts from here and there, 3D printing as much as possible. My initial thought was to 3D print a couple different Vortex tubes and try them out with a regular compressor and compressed air tank, and then move on to, like, once I get the optimal parameters for like different like gallons of flow per minute and things like that, and temperature drop, then move on to seeing what you can do with like 3D printing the mechanical stuff that costs a bunch of money, because I mean, you can get tire compressors and things like that pretty cheap these days, but they are loud and clunky, and they don't usually have a reservoir tank and things like that. So I was thinking something like a few different 3D printed compressors from various types of fans, and see how effective they are and how much pressure I can get into some sort of pressure vessel, be it like a Coke bottle or something like that, and then see if that will hold enough air and enough pressure that I'll be able to effectively cool a part with that. And I also have to consider, like, you know, cubic feet a minute or gallons of flow through a restricted space, and then directing that onto the print, which would probably mean something like the, what are they called? The, like, snap-together air tubes, modular hose, I'm blanking out here. But, yeah, that's definitely something that I want to check out. Especially because I do a lot of prints with larger nozzles as I prototype, like, you know, hundreds and hundreds of stupid things, and I don't run into the limitations because of the way that I've made this printer. I don't run into limitations with like volume of extrusion. I don't run out of gas on how fast the steppers can go. You can stiffen up the kinematics so that they're decent if you compensate in the design of the model for, like, you know, ringing and sharp corners and things like that. But it's getting those big, thick lines of filament cooled down when you lay them before it turns and kind of drags it off of the layer. That's the big problem that I've been running into, which is why I want to look at that. And right now, what I've been using is like an entire chorus of fans if I'm doing that sort of print. So I'll have up to like 3 auxiliary helper fans, plus that hot end has 2 blower fans on it, 2 high flow blowers. And that's like good enough-ish, but I want to get better. Okay, next question. Manuel Conan asks, or says, RepRap firmware has an experimental approach to reducing ringing by adjusting accelerations. It's static, though. You have to measure the ringing period as precise as possible and calculate a parameter from it. Sorry for not being more precise, but I don't use this feature. I just know it exists. Yeah, I went and checked that out, and that's pretty much what I was thinking. That's referring to something that I touched on. Hair stuck on my head. That's referring to something I touched on in the Wacky Ideas video where you would measure the amount of deflection when you go around a corner or make particular moves. Excuse me. And then compensate in the firmware for that, which would require measurement ahead of time. And then some sort of like feed-forward adjustment that you would use at print time, or that you would print to the file to compensate and, you know, readjust the pathing for the G-code. So I'm glad to see somebody's at least working on that idea. So that ties into the next comment, which was, let me see who said that one. There it is. Random guy says, regarding measuring and compensating for the springiness of a motion system, there's a paper that's done exactly that. And I downloaded that paper, and I went to the research website, and I downloaded other papers of theirs, and basically they're doing a extremely fancy version of what the RepRap firmware stuff is doing, but it is exactly what I was thinking. Figuring out ahead of time how much your deflection is, and then compensating for that in firmware. Now, they are compensating for that in real time using a secondary board for the pathing. And if you look at the paper, they included all of their math, which is fine. I realize you have to do that in those papers, and it looks incredibly complicated, but it's not incredibly complicated. It's just a lot. And I would rather they have included the algorithm in there, or at least a block diagram of how the algorithm works. Maybe that's in one of the other papers that I haven't gotten to yet, or they just haven't released that information yet. I don't know. But I also saw they got a whole bunch of pushback from the community who didn't understand what they were doing, didn't fully read the thing, and attacked a bunch of their methodology, which was nonsense. They just didn't completely understand what was going on. So if you do check out those papers and stumble onto the community screaming at them, just ignore it. They are interrupting that feed, sending it out to another machine that's then recalculating those. And at first I thought they were doing some sort of like resampling interpolation. It might be kind of what they're doing, but they're actually repathing it using B-splines, which if you're familiar with those, you would be familiar with those if you ever use like a vector drawing program or something like that. But it's a vector shaped type of thing that will use higher order polynomial calculations to make a smooth arc, or kind of like approximate a smooth arc. And I'm actually pretty familiar with all of that because I've done a lot of programming for like audio digital signal processing, and to get rid of aliasing and things like that, or to make hard filters, you're doing a whole lot of polynomials and then rolling them into like an FIR filter bank and convolving them with the signal. And I had to write a couple of those types of algorithms for scratch, even though I usually use like on-the-fly IIR instead of FIR kernels to do my processing, because it's A, lighter on the processor, and B, doesn't have the latency problem that you do with those. But anyway, and they made a real big deal about their filtered B-spline interpolation, or I don't know if it's interpolation, their filtered B-spline algorithm. And I guess the filtering is just standard windowing, it seems like, from what they said in the paper, which truncates the size of the kernel a little bit and makes the computations quicker, which I guess is necessary if they're doing it in real time. I don't know if you have to go, I don't know if you have to do all that, and obviously that's not possible on little 8-bit MCUs, or even maybe the 32-bit MCUs we have on these machines. You're certainly not calculating polynomials on an 8-bit AVR, not to the orders that they would need, and then repathing in real time. I don't know if something like Klipper could incorporate that, or if they would even have to, because I think you could probably take like a similar idea, as long as you know the deflection amount and the period or frequency, whatever it is. It's something that you could compensate in either the slicer or the USB host or the serial host or whatever you're sending it to. Or maybe you would just make a post processor that you would dump the G-code file into, and it gives you a new pathing file. A lot of the problems that we run into is the fact that we use STL files on G-code, which is somewhat limited in the way that it can handle arcs and pathing and things like that. But real-time may be overkill. B-splines may be overkill. Polynomial interpolation in general might be overkill. But it is kind of what I was thinking, where I'm sorry I have to bring a lot of these examples back to the audio world, but that's what I know best. So if you take something like active room correction, where you take an impulse response of a particular space and you feed that into a computer, you take an FFT of that file, and then you look at where your dips and valleys are in the frequency response, take an inverse FFT of that, which is your room correction, filter that into a particular kernel, and then you convolve that signal with the original signal, which is like a multiply, add, accumulate type thing, and then it corrects the room response. Not perfectly, and sometimes it sounds a little bit weird, but that's generally what I was thinking. And the goal doesn't have to be to do it best or do it 100%. I'm fine with improving things a little bit. And if you could do that with a post processor, great. The problem comes in, obviously, figuring out the actual amount of deflection ahead of time, and then figuring out how to get that into the files or the firmware or the host or whatever. So they use, it seems like they use an extremely sensitive piezo transducers to figure out how much of the deflection was and to get actual impulse responses of the ringing. I don't know if you could do the same thing with like a cheap accelerometer board. And then there's the other problem of if you're talking about like system resonance that you're trying to correct, like that's easy enough to get. I mean, you can whack your printer with a sensor on it and it's going to show you what the frequency response is, as long as you have one that will sense in a proper range, or I should say the resonant frequency, and then you can compensate for that. But that changes in printers like moving bed printers in particular, because the mass of your bed is going to change as you're building up the print on it. Also, you have more or less deflection and changes in frequency depending on where your gantry is on your vertical armature. So there are obviously problems, but I think it's a good idea. Okay, next, when I was talking about being annoyed by the V6 hotend, Ryan McEwen, who has a site that sells Creality upgrades, so some free advertisement for him, he says for a hotend you could use a CR10 MK10 heatsink. It's roughly the same size as the V6. I mention it because it has two mounting holes in it that are 3 diameter and they are flat. There are two varieties, the older M6 threads for the thermal tube and the latter smooth outer diameter, except for the bottom, which is M6 and threads into the heater block. They actually perform very well, and I personally prefer the earlier version. Yeah, I have looked at those. I was looking to buy some of the earlier ones with the M6 threads, because if you don't know, these... I already lost my thing. These E3Ds, this is M7 threaded, which nobody uses for anything. I don't have one of those other types of hotends on here, but they use like the, they've switched to like the micro Swiss hotend style, where you have a heat break that's smooth and it just fits into a bored hole and it's held down with a grub screw or a set screw, whatever you want to call it. And maybe that's fine, I'm not sure. I'll actually have to test that. So yeah, I was looking for one of the older ones, and I just did like a Banggood, eBay, AliExpress thing and found as many different mutant type of heat sinks that I could. But yeah, thank you, Ryan, for the recommendation, and I will be barking up that tree a little bit. When I do the, DIY hotend type experiments, things like that, I'm going to look at that style of heat sink and what we're talking about in terms of this vital bottom fin here that's right where your transition zone is. It may or may not be okay depending on how much heat you can pull out of that, how quickly. And with heat sinks, we know that surface area is more important than thermal mass, which tends to retain heat, but I don't know how quickly that's pulled into the rest of the heat sink, and I don't know how well it works with a all-metal hotend versus like a PTFE sleeves hotend, so I'll be looking into all of that. Okay, Joe says, if you don't like the E3D groove mount, they are working on a threaded version. Yeah, after he said that, thanks, Joe. After he said that, I went and I looked at the E3D blog, and they are working on a threaded version. That's pretty nice. Yeah, the groove mount interface just kind of annoys me. And I'd thought of making, like, you know, little thread-on adapters and things like that, which isn't actually all that tough. It makes for a much more solid interface, which is nice, and it can go completely from the top or a little bit more remotely. The actual mass of this may not matter, or you can cancel out by putting a mass on top of it to counterbalance it, so instead of swinging, it just stops. I don't know. But those are other things that I want to look at. Christopher Rumstead says it would be fantastic to see a compact pellet extruder being able to use recycled plastic bottles rather than having to buy rolls of filament, which would save on money and save our planet. Interesting idea regarding the induction hot end. That's something that that could be implemented fairly easily. Yeah, I actually wanted to suggest in that video a like auger Archimedes screw style like feeder with a hopper or something like that. There would be like either a raw pellet extruder or something that grinds up used parts and then prints it directly. The problem was regulating the pressure, so I don't know if there would have to be some pressure tank after that, and like a pre and after cooker. Might be easier to extrude it into filament first and then feed that. And I think I saw there's definitely like DIY filament maker type things that kind of work, and then I think I saw a recycled filament pellet hopper to filament maker with that sort of setup, but I don't remember what it was off the top of my head. But yeah, I'd like to see some more ideas poked around in that area. UC Berkeley did a video a little bit ago, and I've seen a couple other places, so it is in the public consciousness at least. Peter Ellis, this is in response to my saying I'd like to see some closed loop stuff. It would be fantastic. Or he says, also, have you seen, and he posted a RepRap link, it converts the X and Y stepper motor driver carries into quadrature encoder closed loop controlled DC motor drivers. It's ugly, but you'll never miss a step again. I did not see, the link that I went to and checked out was, it looks like MKS took either like the, I forget what the two projects were. There was Mechaduino and one other one that did like a closed loop stepper system. And I was going to just like on a whim grab one of those, but it looks like they only sell the entire, like they sell the stepper itself with the board and all that crap, and I don't want to buy all that crap. But if they sell just the board, I'll pick one up. I don't have one of those Mechaduinos for the same reason. And there was one other one that I don't remember what it was called. They came out like last January or something like that. But yeah, it's good to see that cheaper manufacturing has picked up that idea, and maybe they'll run with it. I would like to see something like that on the extruder as well, where flow is much more vital, but that would actually be really easy to implement, and I may do that myself with the extruder test if I have time, fingers crossed. Mega Making says, Klipper already does that to some degree, not exactly the full back and forth communication between MCUs, but it does support multiple MCUs and spit out the steps and PWM signals. He's referring to, I said it would be nice to see some little satellite MCUs that would be able to sync up with each other. I suggested CAN bus would be the best way to do that. I'm sure Klipper does it over the typical serial, and it's nice to see that sort of thing going on. And I know Marlin has like an experimental I2C bus that'll do sort of that type of thing. I2C is not very fast, but it might be fast enough. I'm not sure. I'd have to check it out. Lord Zal says, thanks for the nice videos. I'm also looking into a 32-bit board. I don't know about the GTM32 ones before. GTM32 Pro VB has schematics, pinouts, and information on connectors, and several LEDs available. I would also like that it's 24 volts and supplies 12 for the fans. It also has dedicated port to connect LED strips if one needs that. The downside is it is probably not supported by Marlin or any other of the open source firmwares, but with all this information I might still be able to port one Klipper or Marlin to it. Yeah, you could definitely port Klipper or Marlin to it. There's actually only like 3 or 4 of us, and I say us because I've contributed a little bit to that. Very little, because I have very little time. But you can get STM32 base boards working. I have gotten STM32-bit boards working, and STM32 chips are the first 32-bit commercial 3D printing chips that were out there. It's just that Arduino went to Dua, which used the LP series chips or the NXP, whichever they are, and did not use STM32, which I think was a mistake, actually. So like Marlin and a few of the other firmwares have kind of gone into those and are spending a lot of development time like decoding some of the eccentricities of those chips, and some of the others have just been picked up by the community, and you have like basic functionality and support. I did piece together a couple different 32-bit controllers for printers and tested them out. It does work, and I'd love to do a video on it, but I think the USB communication's still not there, and trinamic support's not there. So those are some biggies, in addition to a few other things, like the UI is a little wonky because there's like an intermediate HAL in Marlin 2, and I don't feel like writing it, and I'm hoping somebody else will. So all that's to say that like you could probably, with some effort, get some version of Marlin on there with at least remote printing off a disk, like a SD card working. Klipper almost certainly. Wick says, I thought heat exchange depends on surface, not mass. I guess having a 4 or more layered board would just add to thermal inertia. Once saturated, the internal copper cannot release the heat. Internal layers are useful for cooling, unless I'm wrong. Yeah, he's referring to, like, excuse me, when you say like better cooling from a 4-layer board as opposed to the 2-layer boards. The reason for that is you can optimize the board structure more. It's not just about the fact that you have more copper, and obviously when you have that sandwich between, you know, layers of garolite or whatever it is, they're going to be insulated very well and not give off heat. But you can optimize the surface area by not having to cut tracks in your top and your bottom traces as much. You can keep like a solid ground plane and then like a solid cooling plane, and then internally do all of your routing so that you get slightly better heat dissipation. And going from like a well-designed 2-layer to well-designed 4-layer with the proper thickness of copper traces and things like that, it's not like you're going to get 3 times the cooling or something. That it's more like in the tests that I've run and stuff that I have seen, it's more like, you know, 15 to 30%, usually around 20-25. But, you know, every bit counts. Michael Trifon says, I know there are a lot of Klipper fans, and I have to say that I think the concept is cool, but why not just get a 32 board and a 32-bit board and be done with it? My comment's not an attack. In concept, it's really cool. Yeah, okay. If you look in that 32-bit boards video, I have some of the price breakdown on the little picture of the spreadsheet that I have. And Klipper's something like, if you already have a working like Ramps 8-bit system, you can get 32-bit performance out of that if you just add a Raspberry Pi. Of course, Raspberry Pis are not cheap, and it takes a bunch of effort, some Linux know-how, but yeah, it is a cool idea. And I do like the thought of having a 32-bit general computing board to do particular things and then send dumbed-down commands to the 8-bit MCU. Or you could always think of it as like, you can also send dumbed-down commands to a 32-bit MCU just as well and get a much higher pulse rate. Now, eventually you're going to run into where you can't feed more pulses into your stepper and have it do anything, or you can't feed more pulses into your stepper driver and have it do anything. But even if you max out what your input can handle, then you do have, in the future, I would say, other more complex computations that you could use on that 32-bit general computing platform, or 64-bit or 128-bit in the future, or whatever, to then send to a smaller MCU. So, you know, CPU to MCU. And that could refer back to the discussions on like synchronizing different servos, using satellite MCUs, being able to like script things on the fly and use like simpler modules instead of having to like recompile firmware in like hard C and send it in there, upload it to your, you know, your onboard SRAM. Being able to take like a modular approach with like the feeder board with just, you know, simple Python scripts or something like that. Or doing what those fellows did with the B-splines and like using that to synchronize your adjusted pathing back with the G-code files that are being fed in, crunch that in like quasi real-time or buffered real-time, and then spit out the result to the MCU instead of having the MCU have to do any math, that sort of thing. So that's why I think it's a cool idea. Whether or not it's economically better than just buying a 32-bit board and going with Marlin, like that really depends on if you have a Pi lying around and, you know, that sort of thing, and if you're any good with Linux. Plus, it's Klipper's tied into Octoprint, and Octoprint's also dependent on the built-in serial drivers for your particular host machine, be that your Raspberry Pi or your full-fledged, you know, desktop computer. And as we know, those of us have had to work with real-time operations spitting out over emulated serial terminal from Windows. It's not something Windows is very good at. Linux is very good at it, and macOS is very, very good at it. Not Windows so much, when those packets are very small, like bytes. So obviously there are pitfalls and problems, but there are also benefits, and I like the fact, even if it's not a firmware that I use all the time, I like the fact that it exists because of that modularity and expandability in the general desktop computing part of the firmware. I lost myself halfway through the sentence. Anyway, I like the fact that in the future you may be able to plug other things into that and have some kind of on-the-fly module add-on mod sort of interface that you can use to make it do additional cool stuff that would be much more complicated on a compile and upload type firmware. Anyhow. Simon Vasiliev, did I say that right? Says, thank you very much for this video. Will you make a video on the TMC 5160 breakout board and the TMC 5160WA? Thank you in advance for your answer, and thank you for sharing your good work. Yeah, as I mentioned before, that's one of the things I'm waiting for with like the high voltage, you know, torque step stick comparison video is not so much the breakout board, but the 5000 series in step stick form factor that I can then A/B against like the other trinamic boards. And there are apparently prototypes floating around in the world that when I get finished some of this stuff, I'm going to try to get my grubby hands on, if they don't beat it to market and get it out there to the general population first. But I would love to do some testing on that. I'll happily alpha test those. And as far as the trinamic breakout boards, they're great. They're a little expensive, but that's part of like when I eventually get to doing the, you know, modular versus integrated board thing, show how you can use those types of breakout boards as your actual printer driver, because they're nice since they have a whole bunch of more area to dissipate heat and whatnot. You could run them hotter, run the stepper drivers hotter and at the more optimized range with larger steppers and things like that, by just instead of plugging step sticks onto a board or soldering the chips onto the board, using those breakout boards with all of the control circuitry on there and sending your step information from your firmware directly from the MCU to those breakouts, as opposed to sending it from your MCU to your controller board to your step sticks to your steppers. And if you go to like digity.com or something like that, you could type in any of the Trinamics chips like -bob, and it'll show you all the different breakout boards they have. And they're like, as opposed to paying, you know, 10 or 15 bucks for the regular step stick form factor, they're like, you know, 20, 30 bucks or something like that. Okay, and I will end this with this next question statement from N. Sabanovich. And he says, love your videos, man. There's something more to consider when using Stealthchop mode. It does not handle abrupt stops. It needs to be ramped down, up, so that stuff like end stops or junction deviation may cause them to shut down. It is more of a problem when running Klipper because it can move a lot faster, I guess. I have to say that I'm referring to this info from a comment on it. Yeah, okay, from Klipper, blah, blah, blah. This is very true, and it is a problem that I ran into I think it was February, beginning of February, late January, something like that. No, I think it was like the second week of February. And that's burned into my brain because it got inadvertently tied into a big thread about shifting layers when the Marlin crew made some pathing errors that were causing abnormalities with various drivers. And it got quite heated and it was very long. And I was of the team that was saying, trinamic drivers have their own very peculiar issues that I've experienced and other people have. We need to take those and separate them from the main discussion and do additional testing and then look at the pathing separately, which seems reasonable, divide and conquer, that type of thing, and narrow down your variables. And from my tests, I found exactly what Ennis was saying, which was there are particular moves that you can set up your trinamic drivers for where, unless you have the current turned down a bit, they will think they're going into overcurrent because of the back EMF spike, and the drivers will temporarily shut down until the current drops, which of course the current drops immediately, so they will shut down and then momentum will carry them to shift the layer, then they catch back on again and start printing, and you get this, like, every time you go over that particular move you get like a stair step thing. Unfortunately, some of the people in the community were saying yada yada yada, your steppers are not set up right, blah blah, you're overheating and things like that, which you've seen the setup that I have for these types of things. I have enough torque on this machine over here to like pull a bank over. It's also geared down 2-to-1. I'm using oversized steppers. I have 2 cooling heat sinks on each of the trinamic drivers, on the top and the bottom, and forced air from a blower through it, so there's no way they're overheating. I also put a thermistor on top of them so that I can measure the heat of the package die right at the interface of the heatsink, and they were nowhere near overheating. Unfortunately, when I did a little bit more digging, it just trips the short to ground flag, which isn't particularly enlightening in terms of troubleshooting. And I had 5 or 6 conversations with Trinamic about it, trying to nail down the problem. And they basically said what Ennis had said. It ties into a few different problems. So you can easily have like a back EMF current shut down temporarily, and you have a situation where particularly with Stealthchop 2 that has like a pre-regulator where it tries to predict and adjust accordingly, where if you have some kind of, if the timing in your firmware, like Marlin for example, spits out uneven step pulses because of the way that, like, you know, junction deviation or one of those other types of you know, the jerk or acceleration settings work, depending on if you're using like S-curve or trapezoidal pathing, trick the smart driver part of the Trinamic board into there, in particularly Stealthchop, and make it think you're changing current. It starts to change, and then once you've pathed onto the new line, you're actually running at the rates that you were before, but it has already started to make current changes, and then you get the same thing where you have like a temporary shutdown, which is super annoying. But consequently, Ennis pointed to where Kevin from Klipper had run a bunch of tests months ago and figured out exactly what the problem was, how to replicate it, and then kind of like figured out what to do with the firmware because of it. And I wish I had looked at that thread a long time ago. There was no reason I would have thought to have just go over there and looked, because I replicated a whole bunch of those tests on my own and spent probably the better part of like a week and a half or 2 weeks like running experiments to like nail that problem down, where he was already set up to do all of that and had it nailed in a couple days. So anyway, thanks Kevin from Klipper for doing that work, and that's a problem that I'm going to touch on with Stealthchop 2 again when I do the next stepper torque video. So alrighty, that's everything. Thank you for sticking around if you did. Sorry I didn't get that extruder video out. Like I said, 2 hours is a bit much, so I'm going to try to get either an edited version of that out if I can sometime soon, or a completely different video where I just start talking about kinematics. If you have any further questions or comments, leave them in the video description. It might take me a few days to get to them, but I do try to read all of them. I'm one of those crazy people that always reads the comments, so thanks for checking it out. Until the next video, get out there and make something awesome.